I'll just start. I think I tried to make this as simple as I could to teach as many just basics as I could. So this is a tutorial on the sequel to the cult acclaimed Tale of Zalde from last year. Tale of Zalde 2, The Adventure of Zalde. The main character is Zalde. He is a boy and you play as him. Basically, this is just the simple workflow I know. I don't have this too super scripted, but everybody just has a blank project open, a blank 3D project open. Is anybody familiar with why you wouldn't see grid lines? I think there's a button right here. Top, it's the Y with the grid. At least toggles it for me. All right, cool. Let's throw some stuff in the scene. Why not? We're gonna come over here. We're just gonna grab a plane. We want a floor. There's our plane. We want it bigger. So we are just gonna grab. Here's a quick thing to learn that, and this works with most 3D softwares. When you have an object selected, if you look at the top 4 letters on the keyboard, Q, W, E, and R, Q is usually the select tool in some regard. W is move, E is rotate, and R is scale. Like, the letters don't refer to anything. It's just the fact that they're the top letters. So you can just go there quickly, press R for scale, big floor. And we can also come over here, and this is the position. We're just going to set that back to 0, 0, 0, so it's easy to know where everything is. Then we're going to slap our character into the scene. We're going to come over here, right-click, 3D object, capsule. Drag him up using W again to access this tool. And here is our character in the scene. We can move the sun out of the way. And that's good. So we got our objects. Let's use a little bit more definition on him. I'm going to set him into the middle as well. And we want to give him an epic sword because Zalde would be nothing without his trusty weapon. So we are going to come here. We're going to make yet another shape. We're going to make a box. And we're going to throw that into the center of the scene again. This time we can make it a little bit smaller, but we're going to make it longer in one direction and just add a perfect sword to him. I've been modeling for years, and this is where we've achieved to, is this. And now, basically, we don't want him to lose his sword. So we're going to take that sword. Oh, actually, we should probably name a couple of things. Capsule. This is Zalde. And then this cube is his sword. To rename things, you just click on it once to select it, and click again where the name is, and just kind of wait, and it'll pop up. Now we have Zalde, his sword. We're going to give the sword to Zalde. Now you'll see this little drop down here. Zalde now has the sword, which means if we move Zalde, his sword stays with him. Awesome. So now we're going to make Zalde move. And I'm going to be completely honest, I'm going to be referring to my own code half the time. I'll type it with you, but that's the way I work fastest, being able to refer to things I've seen before. So you'll get to see kind of my workflow and how I make things. So we're going to come down here to the assets. And I'm not going to do a bunch of organization, but you're welcome to do it on your own, or at least know how to do it. There's folders down here, and this is, your assets folder, which would be in your documents. You can right click here, create folder, name it whatever you want, and there's your stuff. We're going to put all our stuff in the stuffs folder for right now because I'm not going to waste your time with organization. So once we're in the stuffs folder, we're going to right click, create again, and we're going to get a C# script. And this one we can call whatever we want. We can call it like, this is the Zalde script. This is where all the code referring to Zalde is going to be. And here's the part where I'm hoping is going to go smoothly because we've had the Unity tutorials. We're going to double click this and it should open it in your preferred text editor. I have Visual Studio Code, but I think a lot of people here just have the Visual Studio that goes along with Unity. We have our Zalde script, which is now opened here. Here's my Zalde script, or it's called movement, but that's because I was working on something. So let's set up some basic variables. Basically, we can come up here and first of all, we're not going to need start or update for this. Well, we're not going to need start. So we're going to delete that. And we're going to add some variables. We are going to need, so first of all, when you're creating a variable, it's as simple as, generally a lot of the stuff you're going to want is public, but public basically means you can access it from the editor, and I'll show you that in a second. We're going to write public. We're going to choose what type of variable it is. So for our speed, we can make it integer is fine.
And we'll just go ahead and say speed and set that equal to a number. This is just a base number we can set it to. We can modify that later. What we're also going to need is to get access to something we haven't created yet. So we're going to come back here, and I can show you what we were talking about with the public. So we can click here on Zalde, and basically we're going to come over here to this side. You'll see these are the components Zalde has, and we can give the Zalde script to Zalde. Make sure you have him selected, or you can drag it directly onto the model. And here we are. We have the Zalde script added, and with over here we have our public variable. If we make sure to save this so that it updates, when we come into here, when you have Zalde on here, you can see there's 5. The 5 we put, you can change it. It'll override whatever you type here. It will override what's in the code. Cool. So right now we want Zalde to be able to move like a physics object. We want him to be able to fall. We want him to be able to touch things. So we're going to come over here to add component, and we are going to add a rigid body. Just, you can type part of it. It'll autofill. There's a rigid body. All the default values are pretty much just about fine. The one thing we're going to do, though, is we're going to go ahead and go down to constraints, and there is, you can freeze the position of the rotation. We obviously want him to move, but we don't want the rigid body to affect any of the rotations. We will be changing the rotations by hand. So we have the rigid body. Now we're going to go back to our code. And what we're going to do is we want to get access to that rigid body to be able to do things with him. And as you'll see over here in my code, we can literally just say public rigid body is a type of variable, and we're just going to call that player. So there we go. We have access to the rigid body now. But what you'll see is when we go back to the game, when it updates, we have a slot here that says player, but it says none, no rigid body, because it doesn't know what rigid body we're trying to access. That's as simple as, here's the rigid body, click, drag, we have the rigid body. Let's add some basic movement. So you'll see down here, we didn't delete update yet because you'll see here I have fixed update. Fixed update and update are two different things. They are both loops that run as the game is running, but fixed update specifically, the best way I've had this explained is that update runs based on your computer, which means depending on how well your computer is running, things will run faster or slower. But fixed update guarantees that things will be done respective to general time and not just how fast your computer can run it. We are going to now modify the player's velocity. And so we get to this slightly bigger line of code here. Basically, we can grab the player and their velocity. So the player is the variable we made before. Dot means access something it has. And velocity is something, we haven't made a variable called velocity. That's just in Unity. It knows its velocity because it's a rigid body. And we're going to create a thing called a vector3. A vector3 is like any coordinate system you've seen where it has x, comma, y, comma, z. And we're going to set all of its x, y, and z. And so this, again, looks like a lot more code than it really is. But basically, input is something that comes directly from Unity. And it says get axis horizontal. And Unity in Unity, it has essentially, you can set various control schemes that instead of saying, I want to press A and D to move left and right, you can set what the horizontal axis is, and it will basically be able to calculate that for you. Thus, horizontal here is actually going to be numbers from -1 to +1 on whether you're pressing A or D, or W and S for forward and backwards. And since that only goes from -1 to +1, we're going to want to move the character at varying speeds. So we can just multiply that by any speed value we want to move him more or less depending on the speed we want. For the Y, which would be vertical, the one thing we're going to keep the same is we want to keep his vertical velocity the same. We want the player to be able to drop at the rate that the rigid body is going to calculate. So we'll just grab his Y and keep it there. And so, if I'm not mistaken, that should be all it takes to get him to move. I will, again, I'm working with you, and this is where it'll be, you'll get to see how I make sure things are and aren't working. We'll attempt to run this. We'll come here. We have the Zalde script on. We have the rigid body. Hit play. I'm very glad that worked. Look at that. We have a moving Zalde. Mine's rotating. You mentioned earlier, missed it. No problem. So we'll drop out of play. when you come to the select Zalde, and you're going to go to his rigid body, there's a drop down for constraints, and you're going to freeze X, Y, and Z. Zalde will end up rotating later, but those constraints keep it the rigid body from calculating the rotations. Let's make Zalde jump. So we're going to come over and look at my code. We can make him rotate first, since we already have the movement working. It'd be nice to be able to visualize that. So the way I did that was basically, I got a custom type of velocity from the player. I could grab the player's velocity, but that includes all directions. But we don't want to know all the directions he's facing. We just want to know what way he's, yes. When it comes to X and Z, we don't want to know how fast he's moving up or down. But if he's moving a certain speed in the X and the Z direction, we can tell kind of which way we're currently moving, and we can just make him rotate that way. So we can make another vector 3, but this time we're going to name it. So VEL is just something temporary to call it. And we'll just create a new vector 3, which is something you'll see is very specifically used for vector 3s, whereas other variables don't need the new. You need that for a vector 3 because it's a slightly more complicated data type. And then basically our vel that we're going to hold on to is the player's X velocity, 0, and the Z velocity. Moving right down to the next line, what we can do is basically say, if the velocity does not equal a vector that is 0, 0, 0, which turned into simple English terms is, if we are, this says not moving, we have no velocity. If we are not moving, which means if we are moving, we're going to do this code, which what we're going to do is we're going to set our direction. Our direction is a variable we need to set up. And we're going to come up here and we're going to go to another private. This one's a quaternion and direction. My understanding is quaternions are very similar to vector 3s, but they have slightly more information and it works really well for keeping track of the player's rotation. So we're going to stick with that. So we're going to create a quaternion that is direction. And then down here, we're just going to set that direction to this. This is a special function that quaternions have in Unity, which allows us to look rotation. Look rotation is something it can do where basically, given this velocity we have, we can get a quaternion that represents looking in that direction. And then since it's saved into direction, we can just say game object transform rotation. So we're going to change the rotation of this game object, since we've said nothing other than game object, it's referring to this game object. We're going to set its transform rotation direction to that and look towards that. So with just these lines of code added into our previous code, we should have a Zalde that is now facing the proper direction. I do believe we saved that. Make sure it's saved. We're going to go to our project. I didn't create the variable myself. Save that. And I do believe he should be just fine now. Hit play. WASD. And we have a sword that's facing the wrong direction. If you have that problem as me, it's also probably just not a, you might not have the problem. It just depends on where you put the sword. Make sure the sword is sticking out in the direction of this blue arrow. We'll make that face forward because that's the direction that he's just moving in, and I put the sword on the wrong side. And we should have a just fine moving Zalde. Let's come back. Let's add another mechanic. Let's do jump. This one is decently simple. We have another way of getting input, which before we did input.getAxis gave us that -1 to +1 for how much you're pressing. But right here, we're just going to flat out input.getKey, keycode.space. That's the lingo for how to get that. You can always just Google key codes in Unity if you ever want to know to have a certain button cause a certain thing, but that's just the one we're going to use for this. And then we use something we haven't made yet. Forget this if exists, and we're going to basically make our player jump when you hit space. We're going to set the player's dot velocity, which is just setting the velocity again, to a new vector 3, because we're going to choose X, Y, and Z by hand. And we're going to say, keep the X the same, except we want to jump to a jump height, which is a variable we need to set up real quick. And then player.velocity.z, so we're not changing the z. Let's go up to the top of our code, and we are going to create a jump height. This can be just about any variable. Again, it's a variable you can change later. Go into here. Pick a jump height. And there we go. Let's pick 5 if you want to use the same number as me. And then we're going to basically just keep the code that says this. Do not keep the ground check because that's something we're going to need to check in a second, and you'll probably be able to guess why we need that, hence the name ground check. But if we just have this, if the get key, change the player velocity, let's see what we get. Throw open Zalde, hit play, and look at that. We have a perfectly working jump. Problem is, hence not having a ground check, you can jump infinitely. If you want infinite double jumps or infinite jumps in the air, yeah, you're done. But most people want it that you can only jump once off the ground. So we're going to work on a fix for that. Basically, we need to check for if the player is on the ground. We're going to make a new function of our own. We are going to make a ground check. We're going to come down here, make sure you go outside of your fixed update. And we're going to make something else that we can call later. It'll look like this. Private Boolean ground check. So the thing is, you'll see that this Boolean here is different from here. There's nothing between void. Oh, well, sorry. The private is because no one else is going to use ground check. Just the player is going to use his own ground check. And instead of void, we have Boolean, which means it's going to return a value. And a Boolean is a true or false. So basically, whenever we run ground check, it's going to return whether or not this is true or false. So let's write code that would check whether that is true or false, whether you are on the ground or not. So first thing we're going to do is set up a variable. Yes, how far below the character on the ground we are going to check. This is based on the character size. If you haven't changed anything, the character size should be still at 1. So what we're going to do is we're going to create this distance variable to be able to do math with it. The 0.01 after it, though, is because we want to check just slightly below him, because if we check at the exact height, it would be within the player's body, and we want to be able to check below the player's body. So that's just a variable we're going to create in ground check to be able to hold on to. Then we are going to make a vector to represent the direction we are going to check. We're just going to create a new vector 3 called direction, where it's basically nothing in the x, nothing in the z, but straight down in the y. So it's straight down below the character vertically. We're going to make that also be able to check whether or not the player is touching the ground. Finally, we're going to get to the part that actually does the checking. We have if and this new function, physics.raycast. So physics is where it comes from, and raycast is the function we're going to do. A raycast refers to when, from any point, you can essentially shoot a ray or a line towards a direction and tell whether or not it hit something. So all we got to do is just take player, which is that rigid body of ourselves, our position, go in a direction. So just to prove why we did all these things here, is we are setting up variables to put in here. You could have just as easily, instead of setting up the whole direction variable, made a new vector right here. And since you need a distance that you're going to raycast, you could have put this distance right here. That is just as fine. But if we ever want to use these variables again, it's nice to set them up separately. So we have our distance, we have that. We're going to use our distance and our direction. And basically, this just says if and then raycast. And you'll see we're looking for if that's true or if that's false. Basically, the raycast is going to return true if it hit something. So then we're just going to return true for this Boolean. We're just going to return true and be done with ground check. If not, if it doesn't find something, we're just going to return false. We're not on the ground. And as simple as that, we grab this part. We can bring that over to our ground check. And now we have a way to check whether or not the player is on the ground. And that's where we go back to the code that I told you earlier we didn't want to keep, which is the code that says, for our jump, if ground check. And the way that's worked in its wording is basically whenever we jump, we're going to do something if ground check. Now, we're using ground check as like a variable here because when you run a function, since ground check is a function that has a Boolean, this is going to be represented as whatever we choose to return. So if we run ground check, when we check this if statement, when you hit space, we're going to run this. Whatever this gives back, so if we're on the ground, it'll say true. If that's true, we will jump. And just like that, we go back and turn back in the game. I'll hit space again, but I only come off the ground once before I hit the ground again. And just like that, we have a working movement system. One thing I want to do is I want to make it so we can attack with the sword. This is going to be a very, very simple way of doing this. But obviously you want animations and complicated hitboxes and stuff, but we're just going to make it that when you click, his sword appears and disappears when you let go. So in order for the sword to be able to be used as a sword, we're going to come into the main game and we're going to click on Zalde's sword. And you'll see over here, it has a box collider. So right now, if I were to zoom out this camera, see if I can show a good example of this. If this is the ground right here, since it has a box collider on the sword, if I come into the game and I have my sword, I can jump over here and I can hang off the ledge by my sword because it has a collider. That's what its purpose of existence is. But we don't want that. We actually just want to use the fact whether or not the sword is touching something to tell other things that it is touching the sword. So with the quick click of the box collider that's already on here, we turn on is trigger. You will still see the sword just fine. But now if I go to do a super awesome ledge grab, you will see it no longer catches the edge. So now that we have a trigger in our movement script, I want to check for left clicking. Again, this is just like space. If the input, get key, mouse click, there we go. We can check if you left click. What we want to do is we want to access a couple things. And you'll see we access the sword, and then we're getting a component from it. But we don't have the sword yet. We want to be able to refer to his sword. Again, we're going to come up to the top of movement, public, game object, sword. Public sword object. But once again, just like the rigid body of the player, we need to tell the game what the sword is. So if we go back to our player and scroll down to our Zalde, you'll see that again, the sword has no game object. Simple as grab the sword, give it the sword. It now knows what the sword is. Let's do some code based on whether or not we click or not, whether or not we click left click. So we're going to say if you left click the sword dot get component. So we're going to get a component from sword. Components refer to these over here. These are all components of an object. So if I click the sword, you'll see we have the box collider, we'll have the mesh renderer. That's what we have. So what we're going to do is we're going to get two components. We're going to get the mesh renderer and the box collider. Make sure this is in these types of brackets, and you end with parentheses. It's a syntax, and essentially the parentheses are referring like running a function, like you'll see when we run ground check, parentheses. That's because it needs to get the component. And what you can do is you can dot enable, so that's a variable it has. We're going to set those variables to true. So when you click, one thing it'll do is the box collider, the thing that I said will be able to detect whether or not you're hitting someone, we'll turn that on. The mesh renderer is whether or not you can see the sword. We're going to set that to true. And as soon as you let go, else, we will set that to false. Set it will not be able to hit anybody, and it will not be able to be seen. And with that, also keep in mind, since you won't be left clicking as soon as the game starts, it will immediately set it to false, and you will not be able to see or do anything. So we pull the game back up. Hopefully, as soon as we hit play, we will no longer see our sword. There is no sword. You can see that because I have it selected in the other window. But if I left click, look, our sword is back. And now click to attack, if you want to even call it that. So we have a sword that appears and disappears, but we still have nobody to attack it with. So let's make ourselves an enemy. Let's come back into our game. I'll make a bigger floor again. And we're going to click over here. We're going to create a new capsule. Throw him into the center. Also, little trick: if you don't have any scales or anything set here, you can right-click on transform and just hit reset. It'll reset zeros, and ones. So if you want to quickly just have a object in the middle of your scene, that's a quick way to go about that. It's just right-click reset. And we're going to make our enemy now. Let's give this guy a sword as well, because he needs to attack. So I'm gonna throw him here. He's gonna be on top of him for a second. I'm gonna make him a box as well. Cube. Reset here. Except I'm gonna make his sword a lot smaller for the purpose of the gameplay, because you want to be able to hit them when they're trying to hit you. Ta-da! There's our enemy. We have we'll come over here, name. I could spell enemy and drag the enemy sword onto the enemy so that he holds onto it. Now we just select our enemy and just kind of, oh, not that direction. Just set him down here. Cool. We have an enemy. Let's make this enemy follow the player. We're just going to work from this angle and move the enemy over here. If you want the camera values to keep it as simple as possible, we just moved it -10. Let's get this enemy to move. Here's our enemy script, which is a lot simpler than before. Well, a lot shorter overall. This is all we need right here to get the player to follow. So essentially, we're going to set up 3 new variables. We want a rigid body to represent the player, because that's who we're following. We want a rigid body of ourself. And we also want a speed again. Pick any speed. Here we made it a float. I think I made it an int for the other one. As long as you're using one or the other for your own intended purposes, that should be fine. And we need to make a enemy file. So we'll just come to our project. Again, right-click, create C# script. This is going to be double-click to open that. Here's our enemy function. We're not going to need start. We will need fixed update once again. And let's set up our variables. There we go. I made the speed 3, so it's slightly slower than the player, so it's easier for testing and gameplay. So let's look at what else we have here. So you'll see right here, instead of start or anything, I have public void awake. Awake is slightly different in the regard that as opposed to just when the game starts, it will run this when the object is created. And for systems where something you would want multiple enemies to spawn in later, that's what this is going to matter. And depending on the time we take here, we will get to that. So basically on private void awake, we're going to set our player, which currently has not been set. Now we could go set it in the editor like we've done before, but we don't want to do that because that might work. I remember I was having problems with it, so I had it checked basically for where the player was as soon as whenever it was created. So what we're going to do is we're going to use a function called find that is under game object. So we're going to find a game object, and you can simply just use quotation marks to search for the name of the character you created. Now that has to match exactly the way you wrote the name of our character right here. So if it's the same as you did it the same, it's going to be Zalde, but it's whatever you named it, you can just put it there in the quotation marks. And we're going to .get component because we want the rigid body. We have the rigid body, make sure you put the right quotation marks, the parentheses, and close it off. And so that should allow us to find where the player is, because we want to move towards the player. And we'll do that. Above fixed, make sure you don't put it inside of fixed, because it is its own function. And we have that. So now we want to move towards that player. So we want to have a variable, a temporary one. We don't need to create it up here, where essentially we want to get the player's location. So we're going to make a vector3 that is the player dot position, and we're going to subtract our location. So this is the player's location relative towards where we are, which is important. So since player dot position is a vector3 and the transform of our game object, which again the game object refers to ourself, when you subtract vectors, it'll subtract the x from the x and the y from the y in respective. But once we do that subtraction, since we only want the enemy to like move horizontally, this would be like if you had like a ghost flying around, you wouldn't want to touch the Y. But considering they're going to be walking forward towards you and staying, you know, parallel to the ground, we're just going to change it so there's no looking up or down. This will give us our player location now, this variable we just created, will be able to be used so that we have something to target and move towards when we start now moving the enemy. So if we come back into over here, again, we want another quaternion for direction. I wish I had better explanations for quaternions, but I don't have a full understanding of them just yet. But as you can see, the reason why we're using it again because of the look rotation function, and look rotation is something we very much want to use. So we're going to make a direction variable, and that direction is going to be set to the quaternion look direction, and we are going to look at this player location. And keep in mind, player location is the player's location relative to us. So we're going to have a direction to look from where we are. And then you can simply game object transform.rotation. So the rotation of ourselves, this is ourselves being the enemy now, since we're in the enemy file, is equal to this direction that we just set, which is looking towards the player. Now we're going to have the enemy looking in the direction of where the player is. And with one final step, we want to make a vector 3 for our velocity so we can set our own velocity. That velocity that we're going to have is take the vector of our forward. So basically, we just rotated ourselves towards the direction of where we want to be facing. And what we can do now is grab the dot forward from our transform, which means it's going to give us a vector that is x, y, and z that is in the direction which our character determines is forward. But the special thing about a forward vector is it is going to be a length of 1. So if I was facing perfectly, like let's say towards positive x, our vector would be 1, 0, 0. But as that vector looks in various different directions, the length of it will always be exactly 1, which means if we multiply it by something like a speed, we can get a vector pointing in various directions that are the same length, and we can increase how fast we want to move, how far and how much velocity we want in that direction by multiplying it by a speed. So we'll multiply it by a speed. We'll turn our y velocity to, we want to basically say that the velocity is, before we set our velocity, we want to make sure that that variable we created, the VEL, that the y of it is the velocity we already had in the y. Because if you don't do that, you will slowly fall down or not move down at all as your character is trying to move straight towards the player. Since like we said before, we are looking directly at the player horizontally, but not like vertically. So right here, this just says keep the y velocity we already had, and then this new velocity, set it. That's our new velocity. That's how the enemy's velocity is going to move. And again, if I am not mistaken, we should have a moving enemy. We'll come back to the main game. I don't believe there's anything we have to set for the enemy. Oh, we have to give it to the enemy. No. So make sure you have your enemy selected. We're gonna grab our, our script. We can put it over here, or in this case, I'll just drag it. Enemy. There we go. You'll see the player says none here, but remember, we already set that in the code. That comes from the code that was at the top in the awake. We found Zalde. But since every enemy can refer to itself pretty simply, we're going to grab our rigid body, which we don't have one yet. Just like the player, we want him to be affected by gravity and such. We're going to add a rigid body with add component. And we can grab that rigid body and set that to our enemy's self. Now, as long as we have that on in the enemy rigid body set to self, we should be able to hit play. And thank goodness we have an enemy that follows. You'll see he kind of leaned towards you, and that's because we didn't lock the rotation like I said before, and you can get some funny results of standing on him because of the collisions. If you don't want him to tilt like this, you are welcome to go into the constraints and turn that off. I think it's kind of funny, but that's just a side effect that happened along the way. The rigid body, freeze constraints, freeze rotation would be right there. So yeah, we have an enemy that follows you, but you'll see he doesn't do anything to you. As well, his sword also has that hitbox on, like we were saying, whereas my sword goes through him because of the trigger. Let's go ahead and make his sword go through us as well, since we're going to use that to deal damage. We'll grab his sword, and we'll set his box collider of the sword to trigger. And that should fix that problem. Now we want the enemy to be able to attack us. That's what's important now. So let's find a way to basically, actually, let's attack the enemies first, because that one's a little bit easier. We want a way of knowing, basically, which object in this scene is the player's sword. Now, we could refer to its name, but this way I found is a lot simpler for this. Basically, we can select the player's sword, and there's these things up here called tags. It's currently untagged, just like everything else when you created the default. We can click down here, and there's a bunch of tags that already exist, but we don't want any of those. We're going to hit Add Tag. And you'll see there's this list here that's empty. These are tags that you've created. You can just hit Add New, and we're going to call one Player Sword. Save that, and we have a new tag called Player Sword. Don't be fooled, we're not done yet, because if we click back on our sword, you'll see it's still untagged. So you have to come down here and select Player Sword. So now we know which object in the scene is the player sword, being able to use that tag. So let's program the enemy to be able to say, hey, if I'm being touched by an object with a player sword tag, I die. So let's look at what we've got here. At the bottom of our enemy code, there's a very tiny amount of code that does this, which is private void. So we're not returning anything and it's private because we're only using it. There's a function that already exists called onTriggerStay, which trigger should sound familiar because that's what we set the box to. We have the check that says is a trigger. So the enemy is going to recognize that it is inside of a trigger. And the one thing that basically it is going to be able to, the one variable it's going to have access to is the collider, the thing it collided with, like the sword or any other trigger. And it's going to be known as the name other. So we can use variables from what you're touching. So all we have to say is if other, the thing we're touching, its tag dot equals, which is the way you have to deal with tags, is a dot equals, parentheses, the name of the tag, which I believe I called player weapon here, which is not the same as what I called it, player sword. We're going to call that player sword. I will copy that, grab this for just a hot second. I'm going to come to the bottom of our enemy script still. Keep in mind, this is in our enemy script. Our enemy is checking for whether he dies, not the player. I put this down at the bottom, and this is going to be checked for the tag player sword. And then there's a simple function, destroy, and you use game object. Game object, again, refers to the object that is running this code, and it will destroy itself. And just like that, coming back into our game, you will see that the enemy will run into me. His sword won't do anything to me. But if I click to pull out my sword and just whack, he's now gone. So we have working attack. He's gone from existence. So let's make it so the enemy can kill you, so at least there's gameplay-ish. We have the enemy weapon tag, which we'll go set that up. We have a health variable, which we haven't set up. And that is the health item. Don't worry about that. So let's go set up the enemy tag and a health variable. Let's scroll up to the top here. And simple as this, we want a public float that is health and set it to a number like this, like 3. I set it low for reasons of the way we're going to calculate damage, and we can mess with that easily later. So let's come into Zalde, variables at the top, public float health 3. Cool. We're going to go set up our enemy tag, our enemy weapon tag. Let's go to our enemy sword. We're going to go to the tags, add tag, enemy sword. Make sure you keep capitalization however you're going to remember it. You can pop back out of here. Make sure you set it after you create it. Now the enemy sword has a tag to distinguish that. So give about just a half second to do that. I'll pop the code back up, make sure we got that. Let's write the code for you to die. We will go to here. We're going to do, again, onTriggerStay. Bring that over. We're going to go below our brown check, just make sure you're not inside of anything. We have this private void onTriggerStay, collider, other, I believe you just do onTriggerStay and hit tab or enter, it'll like auto-fill a lot of this. Once we have that, we will now basically say, this is the same as our this is very similar to how the enemy died before. We're going to say, if other, the thing we're touching, its tag dot equals enemy sword. Again, I used weapon for this code. We're going to run some code. And the code we're going to run is our health is equal to now, or I can say minus equals. We're going to set our health to our health minus this thing here, which is a variable I forgot to set up. So we want this DPS variable, which I'm using to represent like damage per second in a video game. If we come up here, we can pick how much damage per second you take. And this is where you can make a lot more interesting of a system where the enemy's weapon determines how much damage per second it does. But this is just so now we can take a differing amount of damage per second. So I was thinking, you know, if you have 3 health, 1 damage per second, you die after 3 seconds. So let's do the damage per second variable and put that up here with health. I forgot that was a variable, so we have that now. And what we're going to want is public float DPS equals 1. What we're going to do is we're going to say our health minus equals, and I could just say damage per second. But the thing is that this on trigger state is going to run a lot. It's going to run as long as you are in the trigger, that trigger of the sword, and as long as that is an enemy's weapon. So you have this thing here called time.delta time. That's not something we made. Again, it's like the namespace time, capital T. It has these capitals matter a lot here. Capital T for time, and the thing we're going to access is delta time. And delta time is something in the game that Unity keeps track of, which basically says, how long has it been since the last time we ran code, essentially. So if your code's running every quarter of a second, it runs code, delta time is going to be a quarter of a second. So if our DPS is 1 damage per second, and it has been half a second since the last time we ran code, 1/2 times 1 is 1/2. So we are going to take half a damage. And as your computer fluctuates and various things affect how fast your game is running, in the end, since you're only ever multiplying by how much time changes, your damage per second will be done in damage per second. And since the only time currently in this game you will ever die is when an enemy sword hits you. So as soon as we change our health, let's just check if we die. And this is where this is not a smart way of doing this. Just flat out destroying the character you're controlling will cause problems. That is the one thing where you'll get problems whenever we die in the game, but that's what restarting a game level is for, or that's what, you know, a death animation is for. We're just going to destroy ourselves to prove a point, but this is where you'd want to write any code that deals with restarting a level. Just as simple as if our health is less than or equal to 0, die. And with just this code written, we'll bring all this over, and I'll leave it up for a second, don't worry, to our on trigger. That should be all the code required for us to die. If you click on our player, you'll see the health variable looming down here. If you make sure he's still selected when you hit play, flip over here. And we are not taking damage. Yay. Oh, I'm dumb. I forgot to change this to enemy sword. This is why you pay attention to your names of things. Enemy sword is the same name that we have for the tag on the enemy sword. Bam, enemy sword will be up here. Now if I click on the player, you'll see right here is that 3. We hit play, the enemy will walk up to me. It's ticking down 1 second, 2 seconds, 3 seconds, dead. Nice. And you'll see that's that problem right there. The object type rigid body has been destroyed. You're still trying to access it. That's the game having a fit that you killed the thing you're controlling. Oh, I think the enemy is still trying to access you, but you don't exist anymore. That's going to be there for the rest of the game. That's why you want a better death system. Let's do the health item because that one was super easy to do, I believe. If you want health with varying health sizes, you would want to do otherwise. Because look, here we are. This is, again, like when we touch the sword, it's checking for a tag of health. This is something I'm not necessarily saying to type just yet. We'll come back. Saying if the thing you're touching has a tag of health, your health is now 3 and kill the thing you were touching, which would be the health object. So let's just go make an object to represent health. We'll come out here. We'll make a new object shape. We'll do a 3D object. We'll do a sphere so you can tell the difference. Reset that transform so we can tell what it is. We'll put the sphere over here. That's beautiful. We'll make it slightly smaller so it's so you can tell that it's the health item instead. Again, I'm not done great at making, this game is not supposed to look pretty or anything. It's just get as many mechanics as we can. So you can refer to this code and go, oh, I want to add this. Here's what we have. there we go. We have an object that's going to represent health. And just like we saw before, we want a health item. So I actually used my same tags as before. We're going to call it health. Right here, untagged, add tag, new tag, health, save, click back on our object, untagged, make sure it's set to health. We'll come right back to our code. I'm going to yoink this code, bring it over to here. And this is the code you're writing, this if statement. And just like that, that should be enough to reset our health and destroy the health once we've already picked it up so we don't get infinite health from it. We're going to click on our player so we can monitor the health. It is right there. In play, we're going to let the enemy beat us up a bit. There goes our health. Oh, he's dead, but we got about 1.9 health. Just come right on over here to our health object, and we didn't make it a trigger. That's why we can't touch it. If it's not set to specifically be a trigger, as in something that is merely for the sake of triggering events, it will collide with you. We're going to let the enemy beat us up a bit, and we're going to kill the enemy. We're at 2.4 health, and now if we just walk over that, it doesn't work. I did put it, now, see, look, now the enemies can heal themselves. That was an intended mechanic. I meant that. We put it in Zalde. Bada bing, take damage, kill him. Health is at 2.3, and we walk over to the health item. It disappears. Our health is set back to 3. Right there, we have working mechanics. The player moves, jumps, attacks. The enemy follows, attacks, and dies. The health gives you health and then dies. Everything here dies. So let's make a way for more things to exist. We want to make spawners for these things because I'm about to show you how we could theoretically make a level. We can make a working level in this game right now with the magic of a thing called a prefab. I want there to be more enemies. So I could copy him, don't follow this, paste him, and literally like that, we have 2 enemies. They're going to both follow me because we, programmed it decently well, I would think, ish. And it works just fine. But here's the thing. I want the enemies to all be bigger. If I change his scale, you'll see he is now thick, but the other ones are not. I want to be able to change all enemies without now having to go back and change all these individual things. So let's make him not thick and delete his brother. Let's grab our enemy and with magic, literally just click and drag it down here to with our stuffs. And now we have an enemy prefab. And with the magic of the enemy prefab, there's a new enemy. There's a new enemy. Hit play. They will all work just fine, and I will die instantaneously. But I want them all to be wide again. So let's make him wide like we were saying. We're going to come here, we're going to change his size to 2. Oh, none of them, the other one changed. I said that would fix it. That's because we changed him specifically. We made him thicker. Now we have a prefab. Double click. This brings us to the blue void for whatever reason to point and prove a difference. This is our enemy prefab. And if we make this boy thick, they are now all thick because the prefab was now changed to thick. So all you do is double click the enemy, you'll be in the prefab, set that back to 1, go back to the scenes, and they're all back to their normal selves. That's a prefab. Now let's grab our health, which we didn't name at all. Health, click and drag, health. We now have prefabs for enemy and health. And you also see this little blue cube over here means it's referring to a prefab, is what that means. We could make a working level by now clicking and dragging all our mechanics into the level and just play it. But then the level is going to be ended really quick and we don't have multiple levels set up. So we want this one game to be fun. Like we want to be able to keep playing on this one level. So let's create a spawner. And this spawner, I think, is a pretty decently well working system. Right click. Let's create a new object to represent it. We're going to make why not, a cylinder. And we're going to reset the transform. We're going to make it shorter. 0.1. So it's just like a little platform. And that'll be our spawner. In case you want to color some things later, and this is going to be hard to see, if you want to make a quick material, which I'm not going to go into details because I don't know well, you can right-click, create, and material, color. And you can just grab a color right there and just yoink that onto any object, just so it's a little bit easier to see, you know, what we're working with. So there's our spawner. Let's write our spawner code, which is the last code we're going to write for tonight. Here's where I have to teach you about something I learned from this club that is such a beautiful thing, an enum. Enums are super cool if you find a reason to use them. This timer is of type float. A float is a type of variable that is a number with decimals. An enum basically says you're allowed to create your own type of variable with your own types of values. So I want to make an enum for the types of spawners. And the types of spawners I want there to be are enemy spawners and health spawners. So a variable that is of type spawn type can only equal enemy and health. There's nothing else. It can't be 7, and it can't be anything else. I don't know. I need another example. So that's how you create an enum. And if you make it public, I believe it's as simple as this. This enum, even though it's written in the spawner code, you can refer to the type the type of variable spawn type in any of your scripts. I believe that's how it works. If I'm wrong, I'm sorry. So let's use the variable type we just made. Let's make a public variable. The type of variable is spawn type because it now exists as a type of variable. We'll name it. We're going to say this spawner. So we're going to basically set what type of spawner we are. We means whoever's running this code, which is going to be each spawner individually. And to set a type in enum, basically you can't just sadly write enemy. It doesn't know what that means. The value is spawn type, written exactly the same, dot enemy. And the beautiful thing about that at least is if you type dot, it shows you exactly what types of enums you have. It will autofill exactly the kinds you made. What you'll see here is I set that to type equals spawn type dot enemy. Basically, I'm saying the default spawner is going to be an enemy, but we'll be able to change that. So let's finally move some of this code over since we haven't been working much in everything else. Let's grab that. We'll come over to our script. We created our variables. We now have created our enum. And now we have created a variable called this spawner, spawn type enemy. Also, I lied. We're going to need start. So now that this is here, let's go back to here. We're going to need void start because the first thing we're going to do is you'll see the timer. I set it to 0 to be safe because the second we start, we want to start our timer at however long our cycle is supposed to be, which means if you change the variable of the cycle timer in the editor, which I'll show you how to do in a second, you know, we'll have a lot better of a time, you know, modifying that. You don't have to change timer and cycle timer. We'll just basically always start at the beginning of the timer. So we'll come here, we'll add the thing I told you to delete. There we go. We have our start and we set our cycle timer. We can come here, back into our scene. We can grab our little spawn platform. We can yoink this over here. There we go. Spawner, we have our type. So this is where if we want to change our cycle timer, we can change it here. It won't modify the code ever. This will always just default it to 10 if you don't set it later. But you can change it here. This should probably be private, but just don't change this. Just don't touch it. But here's where enums are glorious. With a little bit of extra code to make sure the spawner works right, if you click on the spawner and you go down to this, you get a little drop down of only the enum types you can pick. You don't have to type enemy. You don't have to type health. You just click on the one you want. Let's make it actually do that now. You'll see right here is the last code I believe we're going to write tonight. In our fixed update, first thing we're going to do is our timer. We're going to subtract time.delta time. Since we're just dealing with seconds, basically this says if a second has passed since the last time we wrote code, remove a second from the timer. If only half a second, quarter of a second, it'll remove that. By the way, if you ever start looking at the delta time variables, delta time is like 0.000 something. It's a very, very tiny number because your code runs very fast. We're gonna grab timer.delta time. Don't listen to what I said. I didn't say that properly. Timer minus equals time.delta time. Make sure you capitalize time and time, but we also, if your variable wasn't capitalized time, be very careful. There's a lot of times in capitals and nots. Just check how you wrote it and make sure you match how the way you wrote it was. Then If our timer is less than or equal to 0, so our timer reaches the bottom, it's going to start at like 10. It's going to set it to 10. It's going to start ticking down. As soon as it reaches 0, we are going to use a switch statement, which I quite particularly tried to throw in this enum and this switch so that I could teach these things because they are very nice for working in a system like this. A switch statement. Basically, if I wanted to write code to check for what type of enemy this was, I could have said, if the type is an enemy, spawn an enemy. If the type is health, spawn a health. You're going to have if statement after if statement, and that's just going to be a pain to look at, a pain to modify. Then comes the switch statement. You just write switch, and in parentheses, you say the variable you're referring to. This is this spawner. This is the spawner that we have set for this specific spawner. You could also have any integer like variable in there. And what you do is you open up curly brackets and you say case. So the first case we are going to check, and you just put what it equals. If this was an integer, you would literally just say case 7. And it would run the code only if this variable equaled 7. And then you have to put a break to make sure that it stops. Let's undo what I changed. You're going to say case, and you're going to choose a spawn type. Make sure you put spawn type dot, because that's just how enums are forced to work, and a colon. This is the only place in any of the code we put a normal colon. That refers to the end of the original case statement. Why? I don't know. That's just the syntax. And then you're going to put the code you want to run, and then a break with a semicolon. Still a semicolon. This is the only 2 colons in the whole code. You're in a case statement for each of the types, and we get to instantiate. This is a function that Unity has that allows you to create an object. So let's instantiate the thing we want to instantiate. We want to instantiate an enemy. So we want to access our enemy prefab, which we kind of have to go a little out of our way to do. So where is our enemy? Well, first, we have to put it somewhere we can find it. I didn't know this was a thing, but it exists. So we're going to come back here to our project. You do have to follow this part. This is what I got to work. If you don't do it this way, it didn't work for me. There might be ways to just grab it from right here, but it said no. So we're going to come back to our main assets folder. You'll see that here on the left. We're going to right click and we're going to create a new folder and call this resources. Very specifically spelled this way. Unity allows you to use this resources folder to access stuff. Let's go back into our folder or wherever your stuff is. We're going to grab our enemy prefab and our health prefab. By the way, if you don't know this, you can hold shift to select multiple objects. And control. Shift selects a bunch of them, control selects individual ones. Select both of them, click and drag, and you're going to yeet them over here inside of your resources folder. You shouldn't modify anything up here, but your resources folder has the things we want to access. Because once everyone has that, again, I'll rephrase, assets, it doesn't matter where any of your stuff is, I don't care, except for in your resources folder that you just created, you're going to have your enemy and your health prefab, which I don't know if I said you need to do, but we need to make the prefabs. So now that we have them somewhere we can access, let's go back to the code. Here we have instantiate, resources. I thought you could just put a folder name here, but apparently Unity said no to me earlier. Resources.load. Load is a function that can be ran from that resources folder, parentheses, quotation mark, and the name of the asset. I had lowercase assets earlier. I don't know why. Make sure it matches the way you named your asset. It might not matter. I'm pretty sure it does. Just match it anyways. The name of the asset, comma. And then we get to put, there's multiple ways you could do this. If you don't put any information at this, I'm pretty sure it just spawns it at the world origin, or it spawns it somewhere. You don't want that. You can then put a location. You can just put a transform. Transform referring to its location and its rotation and its scale. But we don't have a flat out just transform that we want to use. So the third option is you can put where it is, the location, and then the rotation. And that's the example we used. You can use less information and it'll do various things. We're going to do it this way with the 2 commas in the respective spots. So what we're going to do is we're going to say this referring to the spawner, and this is not a variable. Gosh, that makes it so hard to speak. The thing that I'm highlighting refers to the object that is running the code. That is just what the word this means in Unity, in C#. We're going to grab its transform and then its position. And then you'll see that I could just spawn it at its position, but I had problems where the enemies were getting stuck in the floor and then yote into space. And we don't want that because we don't want them to glitch into the floor. So we're going to add a new vector 3. We're going to flat out make a vector 3 for this purpose only and move it up 1 in the vertical axis. That's just all I did, is I basically just moved it up. You could add a variable for how much you want to move it up. I didn't care enough. I just added it there. And then this dot transform dot rotation. You could have just done this dot transform, I believe, but in case you change the size of the spawner, I didn't want it to spawn giant enemies or giant health. Cool. You come right down here, instantiate the health. Same exact code, except you're just instantiating the health instead of the enemy object. Last line of code for tonight. Timer equals cycle time. Same as when we started, you're going to restart the timer immediately after it ends. I'm going to grab the code here. Not delete it, please. Go back to our code. Go right after here. Still in fixed update. Fix the fact that I didn't capitalize this previously. Make sure you match what the name of your, these are the names of your prefabs. Save this. Minimize this. Oh no. Here we are, back here. Let's put less enemies to prove a point. Cool. We have a spawner that is of type enemy. We can now, we should probably make prefabs for this, but I'm just gonna, for now, if you'd like to follow this, just do this, Control-C, Control-V, just copy, paste, move it over here. We can set this to a health spawner. And you'll see cycle time, set it to whatever you want, and we can make this more interesting by, we can spawn enemies or health every 10, no, let's make it short, every 5 seconds, and we'll spawn enemies every 3 seconds. Cross our fingers, hit play. Here's our character. Enemy spawned after 3 seconds, health spawn after 5, enemy spawned after 3 seconds, a little bit longer, enemy spawns again, health spawns again. And bada bing, bada boom. You could throw more spawners around. We can keep collecting health. And you have a fully working game. Why is there a sphere collider on our cylinder? I don't know. Again, if you'd like to just quickly grab, just to make, if you want to play this game for yourself, like a little bit more than this, you can grab our cylinder. We'll call this anything. And spawn. Click, get out of our resources folder. I assume you don't want to put stuff in there that doesn't belong in there. Throw our end spawn in here. We're going to grab our health spawn. Throw that in here. And now we can just enemy spawn, health spawn, delete the health that's already here. We don't need a bunch of health, that'd be lame. And with that simple, after making this whole system on this little tiny platform, a bunch of enemies will spawn in, they will assault you, you murder them all, you grab some health, you kill more. I hope that had a lot of individual little skills and little just quick throwing outs of how the code works to be able to do this. And in the end, I get overrun and I pass away. I haven't seen this yet. There you go. You have a working, infinite, zombie spawning. Welcome to the tale of Zalde 2. Zalde's, the tale of Zalde's adventure, that one.